Okay, so the data in our table is asking about a connection between miles driven and gallons of gas remaining in the car. So the first thing we're going to do is open our linear regression calculator from Schoology and input our data. So I start with 30, that's my x value. Then I always press tab to go to the next data point. So 30, 14, 90, 10, 110, 9.75, 157, 180, 6.5, 225, 3.5, and finally 300 and 0.5. And there's my data. Now I can come down, look at my M and my B, and determine my linear regression equation. So I have negative 0.049. Now, the negative 0.0 is going to stay for sure. The only number in question is this 4. And the 9 tells me to make that 4 a 5. Remember, 4 or less, you let it rest. 5 or more, change the score. So here, we're going to have a negative 0.05. Now, when we look at the B, we have 14.979. So I know I'm keeping the 14. I know I'm keeping the 9. The only number in question is the 7. And since there's a 9 right next door, this 9 says make that 7 an 8. So I've got 14.98 for my B. So my equation is y equals negative 0.05 times x plus 14.98. My correlation coefficient, the R value, is a negative 0.99. That 4 says leave that 9 alone, so we're just keeping it at negative 0.99. Now, some people might assume that because it's negative, my correlation coefficient is bad, and that's not true at all. My correlation coefficient is excellent because 99 is almost 100, and 100, 1.00 would be perfect. The only thing this negative is telling me is the slope of my linear regression is going downhill. It's a negative slope. But as far as how good that regression is, based on the R value, the correlation coefficient, it's really good. So now I want to go over to my table and look at my X values. So the lowest value in this table is a 30, and the highest value is 300. So I'm going to make my X's from, let's say, negative 10 to something bigger than 300 so it shows up. Why not 310? So those are my X values. Now my Y's are a lot closer together. So this one is almost 0. The biggest Y is 14. So I'm just going to say the Y values start at negative 1. And if I go to 16, that's plenty of room for my Y's. But the one nice feature that Desmos does have is I can name these axes. So in this case, I'm going to go ahead and name them as well. So miles is our x-axis, and gallons is the y-axis. And now I don't need my document at the moment, so I can maximize my graph. And here is the detail that I keep stressing in class. Instead of zooming in and out from here, we already set our scale exactly the way we want it. Let's just put this away and go ahead and take a picture, because this is a really good picture of what's going on. So I've got gallons over here and I've got miles down here. So I'll snip a little picture of that. So when you look at my linear regression with all my points labeled on the graph, you can see that the slope of this line is going down, and most of these data points are really close to my line. So that's why, based on the R value, the correlation coefficient, this is a good regression. But again, remember, we're checking residuals. So I just want to point out, right here is the point 110 and 9.75. So at this point, we've driven 110 miles. So now let's go back to our calculator and run our residual plot. So first thing I want to do is turn off my data points. I don't want those data getting in the way of my residuals. And I want to turn off the line as well. These are toggles. I can always bring it back, but for now I'm putting it away. So I'll go down here and I'll plot the residuals. Now, if you notice, most of those residuals look like they're really close to the line. We've got numbers anywhere from 0.5, 0.4. It looks like they're all less than 1 away. So if I go here and change the y values from -2 to +2, that gives us a really good picture of what these residuals actually look like. And we can turn these points on. And I'll take a picture of this and put it in our document. Now, if you notice above, I highlighted that 110 because I want to highlight that same x in my residual plot. This point also represents 110. The difference is, on the graph, 9.75 represents how much gas remains in the tank. When we look down here, this number actually represents the distance of this point to our regression line. Because when we're talking about a residual, we're measuring a distance from our data point to the regression line, like so. And remember, this x-axis is just there to represent our regression line. So a positive residual is going to be above this line. A negative residual is going to be below this line. And a residual of 0 would be on this line. So finally, the last thing we need to consider is, does this residual plot suggest a linear regression is a good fit for the data. So I really want to look at how the data interacts with the regression line. I start with this data point, then I go to that data point. So from here to here, and then back across to here, and then back across again to here, and back across to here again and again. So I have several trips across the regression line, and these points are not in a pattern. So without a doubt, I am confident that this is a very good representation of our data. So I'm going to say yes. And my explanation is the data points alternate from one side of the regression line to the other, and there is not a pattern. And that's what I'm looking for. If both of those things happen, then definitely I can say with confidence that this linear regression is a good fit for my data. And that's how you do question number 4 on today's assignment.